Hello guys, I'm Marina and they are my friends, Kristen and Alessia. It's a great day for physics today. You are very lucky. We are going to know what the time is. But before starting our journey, come with us. Let's see what some men of learning think about time. Good morning.
Good morning.
Good morning.
It's a real honor to talk to you today. To ask you, what is the time in your opinion? Wait, one by one. Let's start from count.
Time is the form of inner sense, that is the absolute coordinate of the knowledge. Time, which also includes the concept of the space, is a mental picture which relates to phenomenon, and so time permits knowledge.
Time is the eternal return of everyone. This life, as you live it at present and have lived it, you must live it once more, and also innumerable times. And there will be nothing new in it, but every pain and every joy and every thought and every sigh and all the unspeakably small and great in your life must come to you again, and all in the same series and seconds.
Pantarei, that is, everything flows, everything changes, and nothing remains still. And you cannot step twice into the same stream. I am the philosopher of becoming, so the change in space and time.
Carpe diem, quam minimum credula postero. We have to catch every moment of our life without thinking about the future, that we can't manage because our life is brief and time flows inexorable.
I disagree. I think that time is the most precious gift that we have, and we haven't got a little time. But we waste our time. We use in fact time for useless things, and not to obtain wisdom.
If nobody asks me what is the time, I think I know. But if somebody asks me it, I don't know to say.
Time is too slow for those who wait, too swift for those who fear, too long for those who grieve, too short for those who rejoice. But for those who love, time is eternity.
I have found that the word time means undefined space where do not stop flow of events, of phenomena happens.
The moon has set, and the Pleiades in the middle of the night. Also youth already disappears, and now in my bed I stay alone. Time flows very quickly, and also youth, the age of love, disappears suddenly.
Time is the secret that God hides from us, and because of this secret, we stay alive for every day miserably.
And sorry, can you tell us about time in physics?
Yes. Time is a measurable physical quantity. In this way, we can order the sequences of the event in a determinate place. Time is measured with the clock, that is an artificial or natural device based on a periodical succession, such as rotation or oscillation.
All the periodical phenomena can be used to measure time. For this reason, men considered Earth as a clock in the past. Also because its rotation around its axis was approximately correct. The rotational movement determines our daytime. The best time in the world are the atomic ones.
Time is a very important concept in physics. Until about 1850, with the classical mechanics, time was considered an absolute concept. Newton in fact said, absolute, true and mathematical time, of itself and from its our nature, flows equably without regard to anything external. Absolute space, in its our nature, remains always similar and immobile. The turning point happened with Maxwell. In 1864, in fact, Maxwell elaborated four equations, which related the electric camp and the magnetic camp, and he affirmed that the electric camp and the magnetic camp spread like waves at a finite speed. This speed was 300,000 km per second. that is the speed of light, and so Maxwell affirmed that light was an electromagnetic wave. Shortly after, there was a problem. Maxwell had claimed that electromagnetic waves could spread also in the vacuum, but this concept wasn't accepted because it was believed that all waves spread in a medium. For example, the wave of sound spreads in air, the wave of sea spreads in the water, so also light had to spread in a medium, and for this reason the hypothesis of ether emerged. Maxwell's equations also created another problem. Maxwell had claimed that the speed of light was equal in every reference system, but also this concept was accepted because it was in contrast with the Galilean mechanics. Galilean mechanics, in fact, affirmed that the absolute speed didn't exist, but only the speed which was relative to a specific reference system. Now let's see what a reference system is. Carmine has organized for us a classical Earth reference system.
To explain an Earth reference system, we have to image a train that moves at speed of 15 km per hour. After, we suppose to have on the back of the train an observer who moves in the same direction and in same way of the train. This observer is observer 8. And he moves at the speed of 5 km per hour. After, we image to have another observer who is fixed on Earth, and we call him observer B. If we could see what observer B sees, we would see that the train moves toward us at the speed of 50 km per hour, so the speed of the train. If we suppose that observer B can see observer A inside the train, observer B will see that observer A moves toward him at the speed of 55 km per hour. So, the speed of the train and the speed of observer A are added up, because the train and observer A move in the same direction and way. If we suppose that the train has a turned headlamp, this way, the observer B should see that the light of headlamps moves at the speed of 300,000 km per second. So the speed of the light and 50 km per hour, that is the speed of the train, but it isn't right.
In fact, the Michelson-Morley experiment proved that ether didn't exist and that the speed of light is equal in every reference system. And so, it was necessary to change the traditional concept of space and time. And so, Albert Einstein arrived. Einstein, how did you think to solve this problem?
The answer was in the concept of time. Let's talk about simultaneity of time. When are two events simultaneous? Consider a man in the middle of two events. If the man receives two rays of light which come from the two events in the same instant, the two events are simultaneous. Let's see what happens if we put a lamp and two screens on the train. The screens are put at the far end of the wagon at the same distance from the lamp. From the passenger's point of view, light hits at first the right screen and then the left one. This means that we are wrong if we claim that the two events are simultaneous. The speed of light is always constant. This is why the two events which are simultaneous for use must not be the same for another observer. Before affirming the events are simultaneous, we have to specify the observer. If they are simultaneous for a fixed observer, it can be the same for an observer in motion. All the troubles happen because the speed of light is an universal constant. In fact, it doesn't adapt to the observer's speed. There isn't an absolute answer. You are used to consider time as an absolute concept of the universe. But you are wrong. In fact, both the absolute time and the absolute simultaneity don't exist. They depend on the observers. For this reason, we can also talk about space contraction and time dilatation. Let's explain these concepts with an example.
Sarah and Adam are two friends. Suppose that Adam goes into space while Sarah stays on Earth. Suppose that Adam fires a laser at the ground which bounces off a mirror, and Adam measures the time it takes for the light to return to the spaceship. From Adam's perspective, the laser light goes straight up and down. From Sarah's perspective, instead, the laser light follows a V-shaped path. The V-shaped path is longer than the straight up and down part. Also, since the speed of light is the same for all observers, from Sarah's perspective, it takes a longer amount of time for the laser light to return to the spaceship. But if Sarah looks at Adam's clock, she will see that Adam's clock reads less time in between when he fired the laser and when he received the reflected light back. So, this means that Sarah will see Adam's clock running slower than our clock. The closer a spaceship approaches the speed of light, the slower the time inside the ship will flow. In this way, we can notice that at high speed, close to the speed of light, the phenomena of space contraction and time dilatation happen.
In order to fix better this concept, we expose the famous twin paradox. They are two brothers, Vincenzo and Vito. Vincenzo is 5 years old, almost 6, and Vito is 18 years old.
Almost 19.
Okay, now we will launch Vito into space in a spaceship at the speed of 300,000 kilometers per second. Are you ready, Vito?
Yes, of course.
Okay, while Vincenzo stay with me on the Earth. Vito, it's time to leave.
Thanks.
Have a good journey.
Thanks.
Where has he gone?
Have you seen this force? This is the speed of light. Let's go, Vincenzo. Almost 12 years have passed. Exactly in 3, 2, 1. Vito, how have you been in space?
Fine, thanks.
Do you remember little Vincenzo?
Yes.
He has grown up just a bit. Come here, Vincenzo.
Hello, Rita. Vito? It's been so long since we met last time. We haven't met for 12 years.
Not for me. Only a few days have passed for me.
Oh,
Don't get angry, Vincenzo. Only a few days have passed for Vito, because he has launched into space and he traveled at speed near speed of light.
oh.
Twin paradox explains that for an individual who is launched into space at a speed near speed of light, time expands and he grows old less quickly than an individual that stays on Earth.
In Galilean relativity, the position of a point, x the first, in a reference system in motion is related to its coordinate in a fixed reference system. In fact, x the first is equal to x minus v14. Lorentz discovered that for the new relativity, the factor x minus v14 had to multiply for a new factor, epsilon factor. These are the equations along the direction of the motion. In the directions which are orthogonal to the motion, distances are equal in both the reference systems. As regards the time, even so the clocks are synchronized in one of the reference system, time that the clocks read in another reference system depends on where the clocks are situated. So t the first is equal to epsilon for t minus x for v divided by c squared. Thanks to Lorentz transformation, the problem was solved. The classical mechanics and Einstein's theory weren't in contrast.
Einstein is one of the most renowned men in the history of physics, and Einstein's fame is due to the fact that he was able to enunciate his principles without making experiments. And only after different years from Einstein's death, there have been some experiments which have demonstrated the theories of Einstein. In 1971, in fact, there was a Afal-Keating experiment. Afal, who was a physicist, and Keating, who was an astronomer, took 4 cesium beam atomic clocks aboard commercial airliners. They flew twice around the world, first eastward, then westward, and compared the clocks against others that remained at the United States Naval Observatory. When they turned, they realized that the clocks read a different time. In fact, the clocks aboard commercial airliners read less time than the clocks of the United States Naval Observatory. And this result was congruent with the prediction of Einstein's relativity. Another important experiment was carried out thanks to the muons. The muons are some elementary particles similar to electrons. They have a lifetime of about 2.2 microseconds. But if the muons are put in a particle accelerator at a speed close to the speed of light, they have a lifetime much longer, about 50 microseconds.
Our journey in physics has finished. From this experience, we have learned that time is an illusion. So, to the question, why don't the events proceed backward, we can answer that, according to the laws of physics, this is possible. Also, we can say that in a distant future, time will be imperceptible because there won't be any change. So we won't be able to distinguish the past from the present and from the future. In this way, one day, the concept of time will lose its meaning.